Hello, this is the North American Mexican. Let's go, go, go. And I hope you have subscribed the film if you like it. This week we are going to talk about parametric curve. Okay. The entire analytic geometry part is starting from here. So what is parametric curve? Parametric curve is the curve is a graph that has each dot has a quality this f t g f t f t f f x t I t. Yes. At interval of t. So this is a parametric curve. A common thing that you need to do is to transform the parametric curve to the regular way, which is y is equal to f something, which is in this form. How do we do this? In order to do this, what we need to do is we need to know what t is actually meant to, and then you substitute t into something else, and you are done. The most specific knowledge of this will be shown at the vector chapter. Okay. So we call the y is equals to something. We call this Cartesian form. C-A-R-T-E-S-I-A-N, Cartesian. And another way that require t is parametric way. I mean, there's another name, which I would also talk about in the vector chapter. Okay, so let's give an example. X is equals to 2t. So you substitute t into something and you are done. This is how easy it is. So actually you are able to see that there is in using the parametric curve, you are able to make some very beautiful things, like using this formula. You can make a spiral. This has a professive name called spirals of Archimedes. Okay. And in this case, okay. So this is how just basically what parametric curve is. Let's talk about how to do the derivative of it. To solve the derivative of this, the first derivative is the derivative of y and the derivative of x function. The second derivative is going to be the derivative of dy dx function and the derivative of dx function. Give an example. If x is equals to t to the power 4th and y is equals to t squared plus 2. Okay, it is required you to find this. So how are we going to do this? To do this, we first get the derivative of this is going to be 2t and this is going to be 4t squared, which it requires you to simplify a bit. Okay, so it's the first derivative of this parametric curve is this. And the second derivative, it requires you to find the derivative of this. Oh my god, I hate it. And the derivative of this, which is 4ts. So you will need to calculate the derivative of this. 2t squared negative 1. That is going to be 1 over 2t squared negative 2. No, negative this times, based on the chain rule, is going to be 4t. You calculate this, divide by this, and you are done. Since it is too complicated, I'm not going to write it on the here. But if you want to show, it should be like this. 8 times 4t divided by this. This is going to be the final answer for the derivative. This is just how we calculate the derivative of the parametric curve. And here we come to the end of this video, and I hope you like the film, and see you next week. In fact, problems, they have many solutions, and my solution is only a part of them. If you have more challenging solutions, please comment below. And don't forget, I will also post my problems there. See you tomorrow!